Hi, we're going to be talking about simplifying some expressions, and we're going to be talking about like terms. We're also going to be talking about using the properties that we've talked about and what they look like. Like terms are nothing more than is more than one term that have the same variables or powers in them. For example, I've got 3x, 4b, 7, 10b, 3, 6y, 5x, and 9y. I have put pink squares around those that have just an x. So the 3x and 5x are like terms. I circled my b's with brown. Those are like terms. My y's, I've got a 6y and a 9y. Those are like terms. And when I'm looking at 7 and 3, those are constants, and those are going to be like terms because they can be added together and simplified when we're working with our expressions. Very important concept number one, and you need to know this. When working with terms that have a variable with an exponent, make sure that the variables and the exponents are the same. For example, I have 9x squared plus 4x plus 5x squared plus x. I've got a 9x squared, as you can see that I've looked at the two terms of 9x squared and 5x squared. They both have x as their variable and 2 as their exponent. I have put these two together through using the commutative property of addition. So I was able to move this over and put 9x squared plus 5x. I'm going to add because all of my signs are addition in between, and I know that 4x and x have the very same variable, okay? So I'm going to add 4x plus x. Not even thinking about it, we have used the commutative property of addition. So when I add 9x squared plus 5x squared, it will give me 15x squared. I keep the variable and the exponent the same and add my coefficients, 9 and 5, to get 14. Plus, I'm going to bring my plus sign down. I've got 4x plus another x, or 4x plus 1x. Don't forget we said anytime you have just a variable, 1 is the coefficient. So 4x plus 1x is going to give us 5x. So you keep the coefficient, you add the coefficients or simplify the coefficients and keep the variable. Very important concept number two. All constants or numbers are like terms, because we know that we can add them or subtract them, multiply them or divide them together. So 18, 2, 17, and 35, all of those are going to be like terms. There's no variable with them. Very important concept number three. When you're combining like terms, be sure to include the plus or the minus sign that is in front of the term. If you don't see it, then it's going to be a plus sign or positive. For example, if I have 9x squared plus 3 minus 7x squared minus 2, I'm going to group my like terms together by using the commutative property. I'm going to put 9x squared minus, notice I brought the minus that's in front of the 7, minus the 7x in front. Using the commutative property, I'm going to take the 3 and 3 minus, because that's a minus sign in front of the 2, 3 minus 2. And when I go and simplify it, I know that 9x squared minus 7x squared will give me 2x squared, and 3 minus 2 is going to give me plus 1. Very important concept number 4. To add and subtract, you must have like terms. You must have like terms. For example, 2z plus 4z plus 3z, they all have a z with them, and I'm going to just add them up. So they've got a variable of z, so I know that 2z plus 4z is going to be 6. 6 plus 3z is 9z. 5r minus 2r is going to be 3r. Now let's try this. If I have 6a plus 5a, I'm adding these two together. So this is going to be 11a minus 3a. They all have the same variable, so I know that 11a minus 3a is going to end up giving me 8a in its simplest terms. Here I've got 7x, a 3x, and a 2x. I start with a 7x. You're going to use and remember your PEMDAS rules. 7x minus 3x, these two together will give me 4x. When I say 4x minus 2x, I know that that will end up giving me in simplest form a 2x. Okay? So you've got to make sure you've got the same variables, and you have to make sure that you combine the terms. Very important concept number 5. To multiply or divide, you do not need to multiply or divide. You do not need like terms. For example, if I'm multiplying the constant 5 to the 2z, I know that 5 times 2z is 10z. That 12 times 3a is going to give me 36a. So let's try these together. 8 times 5n is going to give me 40n. 12 times 4z is going to give me 48z. Okay? The one thing, and the reason why I have it starred, you always want to follow your PEMDAS, parentheses, exponents, multiplication and division from left to right. That's why I have the sun over the top. And then addition and subtraction from left to right. And use your math properties, because we know that we can associate things together. We can switch them around, which is the commutative property, in order to simplify and work our way through the order of operations. Let's look at some of these examples. You have 4 on your paper. I only have 3 up here. You can do 4 on your own, and we'll discuss it tomorrow to see if you got the correct answer. I know that I have got t plus 5 in parentheses, plus 4 times the quantity of t minus 1. The first thing I want to do is I want to distribute this 4 to everything inside of the parentheses. So I'm going to come up here with t plus 5. I'm going to add, because I've got an addition sign here in front of the 4. 4 times t is 4t. I know that I've got a subtraction sign in front of the 1, so I'm going to use a subtraction sign. 4 times 1 is 4. Now I can use the commutative property, because I don't know what t is, so it doesn't help me when this is in a parentheses. But I do know that I can group my t's together and my 5 and my 4. So I'm going to say t plus 4t. Remember, I'm bringing the sign that is in front of the 4t with it. And I know that t plus 4t is going to give me 5t. And 5 minus plus 5, that's a plus 5, minus 4. I know that 5 minus 4 is going to give me a plus 1. So this would be 5t plus 1 for my answer. Here I've got 5x plus 10 divided by 2 plus 3 times the quantity of x minus 1. Always do your distributive property first so you can simplify it and then combine the like terms. So now I've got 5x plus 10 divided by 2 plus 3 times x is going to give me 3x. And 3, I've got a minus in front of that 1, so 3 times 1 is going to be 3. Now I can use and combine my like terms. We are going to look at the PEMDAS rules first. I know I've got addition, subtract, I've got a division sign here, so let's go ahead and do the division here so I can simplify this. I know that I've got 5x. What is 10 divided by 2? That happens to be 5. Plus 3x minus 3. Now I can combine my like terms by using the commutative property. So I know that 5x plus 3x is going to give me 8x, and I know that 5 minus 3 is going to give me 2. So my answer will be 8x plus 2. My writing's a little sloppy. Now we're going to look at 12r divided by 2 plus 3s plus 2 times 2 plus 4 times the quantity of s plus y. We have a lot going on here. So let's first look at this. I know that I can go ahead and divide these two, because I know that 2 will go into 12 evenly. And remember, we don't have to have like terms in order to divide or multiply. 12r divided by 2 is just going to give me a 6r. So what we have done here is we have just simplified that little piece there. plus I've got a 3s. Plus, let's go ahead and multiply this. 2 times 2 is 4. Plus, I need to multiply the 4 times the quantity of s plus y. That gives me 4 times s is a 4s. Plus, because the sign inside of the parentheses is plus, 4 times y is 4y. Now, let's group everything together that have like terms. I have an r. Let's start with the r's. Do I have anything else with an r in it? No, so I have a 6r. Plus, let's look for all the s's. I have a 3s and a plus 4s. Okay? We can group those together. So I've got my 6r, my 3s, my 4s. I've got a 4y, which there's not another y in my expression, and a plus 4. So let's just have that tag along. Let's combine the 3s plus the 4s, which I know is 7s. So it's going to be 6r plus 7s plus 4y plus my 4. And this is in simplest terms because I have no other r's that I can combine together. I have no other s's that I can combine with the 7s. I have no other y's to combine to the 4y. And I have no other 4's or constants to combine with the 4. So I have got this in simplest form. Go ahead and do number 4 on your worksheet that I gave you for your video notes, and we'll discuss it tomorrow to see if everybody got the simplified expression all the way down to its simplest form.